freaking Happy Tree Friends. That's oh my gosh, that's genius. Somebody should make a Happy Tree Friends video game where like you just freaking get slaughtered. Yeah. That'd be awesome.
Legend of Zelda is the best game.
That game is just like, get it?
Okay, so here we go. If we take a look at this, like let's say this is one string color and this is the other string color. This one is 37 degrees and this one is 45 degrees. Okay? And then what we're doing is we're going to be breaking those into pieces. So the 37 one, we're going to say T1x, T1y. And then the orange one, which goes like this, right there, we're going to say T2y. And we'll say T2x. And then we can see that gravity is acting here with mg. We also have to remember that T1 is equal to mg. So now we just do some of the forces. Some of the forces in the x, some of the forces in the y. Some of the forces in the y is obviously what? Oh, yeah, well, it'll be 0, right? Some of the forces, because we're going to add up the verticals, and that'll be 0. Some of the forces in the x must be what? How is this block moving? What shape is it moving in? A circle, which means the sum of the forces must be mv squared over r, which I'm going to say m a sub c, because didn't they ask for a sub c? I think.
Wait, shouldn't you square it?
Yeah, it asks for.
Yeah, it's asking for a sub c. Well, remember that a sub c is v squared over r. Okay?
A sub c is always v squared over r.
Yeah. So now I can color code the. Wait, did I do it right? Is that one and that? Yeah, I think. So I think for in the x direction we have T1x plus T2x, and that's going to equal m a sub c. And in the y direction we're going to have T1y plus T2y, and that's going to equal mg. So I'm trying to go color coordinated there so you can kind of see what's going on.
Looks like Christmas.
Sort of. It's green and, if you had purple, why is Halloween green, orange, and purple? Did you notice that?
It's not green.
All Halloween color decorations, they really like to use green, orange, and purple for some reason. Yeah, maybe. Yeah, it's like green's Frankenstein, orange like the werewolf, and purple's like, I don't know, vampires. Yeah. Okay, so here we go. What are these things? Well, T1x is T1 cos theta. I'm going to say this is theta. I'm going to say this is phi. It's another Greek letter. Don't get freaked out. T2 cos phi. That equals ma sub c. And then this one, which I'm going to kind of need to, well, I need to erase this a bit. Grab. There you go. Move this down here. Let's bring the top of the T down with us. Okay, and then this one is going to be T1 sine theta plus T2 sine phi equals mg.
That's not phi.
What's that?
You wrote another theta.
Oh, I did. Thank you very much. Thank you for catching that. That should be sine phi. There you go.
What does that mean?
Phi is just like theta. It's a different angle. Basically, they're just Greek letters. That's all they are. Okay.
Sound Greek to me.
I know, exactly. Okay, so do we know T1? Yes, we do, because T1 is mg, so this becomes mg cos theta plus T2 cos phi equals m a sub c, and this one is mg sine theta plus T2 sine phi, and that equals mg over here. And then do, like, what we're looking for is a sub c, right?
Wait, where do you get T1 equals?
Sorry?
T1 equals.
Oh, it's given. It's in the problem. So since we're looking for a sub c, I would say to me, the easiest way would be to solve these both for T2. So if I solve them both for T2, I'm going to get m a sub c minus mg cos theta over cos phi equals T2. Check your algebra. Never know, might have made a mistake. And now I can solve this one for T2 as well. That's going to be mg minus mg sine theta all over sine phi. And now do you see what I can do? I can cancel out the m's and then solve everything for a sub c. At least. Okay, so if we wish to continue here, the algebra parade that we're doing, we see that I can then multiply both sides by cos phi. That cancels. Multiply this by cos phi here, and then that's going to give me a sub c minus g cos theta equals g minus g sine theta over sine phi. That's cos phi. And then those two cancel because the sine of 45 and the cosine of 45 are the same. So then that gives me a sub c equals g times 1 minus sine theta plus g cos theta. Interesting. So anyways, the sine of 37 degrees is 0.6, and that makes that 0.4, so that's like 4. And then the cosine of 37 degrees is 0.8 times that makes 8, and so we get an answer of 12 meters per second squared.
At the end, that's so depressing that it just
Yeah, it
becomes
just
that
gets-
simple 4 plus 8.
Depressing? I think this is beautiful.
Yeah, I guess I can see that too. But like, after all that, just simple.
Ask your mom and dad, what's 4 plus 8? And then show them, this is the answer. All of this.
It's got a good effect.
What is the like gravitational constant